which logically is seen as a table, as a table. That every file is structured like a table. Okay, and one table relate to the other table. So that's the relational model. That's the model we've been working on since last semester. Try and mute yourself. Please mute yourselves. So basically, a typical information system, this is a representation of a web-based information system. Any typical web-based information system that is developed and used. Please mute yourselves. We have, if it's a web-based information system, if it's a web-based, it consists of, it works under what we call internet setup. It needs an internet. So we first have to have a workstation, okay, where your machine that you sit on, and make sure that machine is connected to the internet. Make sure that machine is connected to the internet. So this is architecture of a web-based information system. Web-based information system must be utilized with an internet. So let's say this is the internet infrastructure, and then your machine must be connected to it. It can be through any means that you get internet, whether it's in a hotspot or direct connection or whatever means internet can be applied to you. You get it. And so your workstation must have internet. It should be internet-based. That's when you can sign on to things like right now, what we are doing. Without internet, I can't speak to you. So what I'm doing is also an information system that I'm using. It's a web-based. So we have that. And then you see the next connection is moved to web server, a web server. And through the web server, you go to application server. Application server, that is the software that I'm using to teach with you right now. Like, for instance, Sakai is the middleware. It sits in application server. And then that database server is connected to it. So this is where your database sits. So you are modeling a system for an environment like this. So many things come into play. But for us, our focus is the database aspect. And the database server connects to the database itself, which is stored on a disk, okay, in the database server. So this is how the internet web-based information system is set up. Then from the database, you can operate directly to it, what we call direct query, or writing SQL statement directly to it to use the database server from your machine. There's also here an intranet workstation. That is, even though you are through, you can use this information system, which consists of a web server, application server, and database server. This is the information system concerned, whereby the softwares are all on application server. The web server is where the interface sits. Okay, the internet software sits that supports the operation. So that is just by the way. And so these are the elements, and we call this setup, the database server, as a back end, whilst the application server or the web server is where the interface is. If you want to order anything online, even though you are talking to a database, which is a database from the database server, you need to get your software interface, the one you will use to do the order, where you will see as the front end, as the web server, where you will be communicating through internet. The internet workstation and the web server will be communicating directly. And then the web server will pick the application from the application server and connect to the database, and then get the data information through Amazon.com. Amazon, where you can buy anything on this earth. You can buy it from Amazon. So that's the one example we can use. Our application system, we develop our web base. Most of the application system are AI based, web based, and stuff like that. So assuming we have any web based information system we are dealing with, there are parts to it. The first part is where you will sit to actually communicate with that system. Like what I'm doing, my laptop here that I'm using, it will be termed as the internet workstation. Okay, I will need internet. So right now I'm using MTN's hotspot. So MTN becomes my internet platform or protocol. My web station right now is connected through internet to a server. This server is through the University of Ghana server. The Sakai, where I'm able to use the web server, is where the Sakai system. Okay, the Teams that I'm using to teach you. It's an application. So it sits on application server, but then it connects me through the web server. So it's through the web server that I'm able to see that Teams interface. Then I'm able to talk to you. And then the data or any information that I will store, in case I'm doing something that I will have to store data or retrieve data, it will now go to the internet. If I have only the web server and connecting to the database, I will say it is a 2-tier. If I have the infrastructure I have right now, it is a 3-tier. It goes through the web server, the application server, and the database server. It's a 3-tier. Okay, this is what we did last semester. If you remember, we look at these aspects. So basically, this is an infrastructure database that we are dealing with. It sits as the third level of this environment. So assuming like Amazon.com, assuming we have to purchase a book. Assuming that, for example, if we want to access the website such as Amazon.com, it sits where? It sits on the web server. To purchase a book from our home, it sits on the web server and your web browser. So every detail of the Amazon.com is on application server, which connects through the web server. So your web browser connects to, connects to one of the sites, okay, which is the web server. Then the web server, okay, so the web server contains no application logic. It merely presents pages assembled by the application server from Amazon.com via the web browser to you on your workstation here. So that is how it behaves. All the logic that searches available items matching your preferences runs in an application server. So assuming you want to retrieve information from this database server, you write SQL statement. That SQL statement, it sits on what? The application server. It's an application, so it sits on the application server. And the web server just help it to do the arrangement through the internet for you. And you see that on your internet workstation. This is how it works. If it's an intranet, then through the web server, the internet will work. So if it's within one location, internet is within an organization or an enterprise. So if that enterprise, all of them are connected on a certain web server, then of course they can also use work directly to the web server through the application server. So all the company application like the web processor, all the Sakai software sit on the application server here. The Sakai sits on application server. The web server is another server that connects us through the internet. The internet application itself is what that the organization have, or the network infrastructure is what sits on the web server and the database server. And if you have these three levels, we call it three tier. If you only have web server and the database server, is two tier. That means this part of the web server can also hold some aspect of the application. It's a two tier and stuff like that. So that is the basis we are using. And look, that's where the database server is. So all the data about available inventory, your account, your preferences and past purchases, and so forth reside based on the Amazon question, then reside in the database on the database server. So data model are abstractions of what? Databases. So this relational database model is just aspect of the databases that we are using. Like what we have, we did this last semester, the levels of the architecture as well as the structure of the database in three levels, layers of the, so I will just bypass. So here we have seen this already. Database layers. Is this slide what I want to do? Okay, yeah. Okay, so this is what I want to do. Okay. So basically, when you want to design or model information or data, you are doing what we call conceptual modeling. The layers of any database are into three levels. Three levels in the sense that we have four layers, but the levels are external to conceptual, conceptual to logical, logical to physical. So that's three levels, but basically four layers: external, conceptual, logical, and physical. So this is the structure of every database. We are looking at from external to conceptual, not conceptual to logical. That's what we did last semester. And then logical to database physical, where the database first sits. But for now, you have the database, you want to create a database, or you want to model a database, a relational data system. You first have to think of what are the usage of this database. What comes to your mind? What would this database be used for? Before you want, yes.
Please maximize the PowerPoint presentation.
If I run it, I don't see whether I'm okay. That's fine.
Thank you.
So this is the four levels of a database system. I mean, meeting why me patch up. Right. Maybe why. So we have external layer, which is nothing but the views of the database, the views. And these views are not anything, but they are the usage of the database you are thinking of designing or modeling. We want to model information system. What will you use that for? And by information system, the data or information modeling is just the database aspect, not application. So that is the difference between application modeling and the data modeling. And data modeling is what we are doing. So first thing is that you look at the external view of the data. The external views are how the database is going to be used. How? So if you want to model a sale data, what will be your thinking? What will be your thinking? What would they use that data for? Is your thinking. Who are the people who will be using the data? Because in any way, in anything you do concerning information modeling or data modeling, you need to know the people or how this data is going to be used before you think of what to be inside or what you need to put together. So the views, we say the database views are the usages. So view one is one view of maybe the chief executive. View two is the board members. What would they need from the database? Then the programmers or the data department-based heads or middle level managers. So normally in a typical organization, we have middle level, we have lower level, which is the operational level, and we have the strategic level. All these levels of management or skills, they need information. What would they need? From this database you are going to model, you need to be able to satisfy that through your data analysis. In designing a database, you do the end up to give you requirement gathering or which support you with requirement gathering. So that is the conceptual that we are looking at. So our modeling approach will concentrate on conceptually. So from the external view to the conceptual schema is where you do the conceptual modeling. And that's where your data requirements, identify your data requirements. So the external layer is the layer or external model is composed of the user views, which are collectively called sub-schemas. So in this layer, the database users or the application programs, as well as individuals that access the database, connect to and issue queries against the database. Okay, all right, so that is where they sit and write query through the database administrator or the database programmers or the database developers. They will create the SQL statement, the SQL that we learned last semester. This is where you use it. So ideally, only the database DBA deals with the physical and logical layers. The physical and the logical layer is trying to implement the data system that you have gathered, that the database analyst or the database architect or the database designer has assembled or put together. So there are three types of data models that we know: conceptual, logical, and physical. So the conceptual model deals with the high-level model. The high-level model that captures the data and relationship concept in a technology-independent manner. So each rectangle represents an entity. So here, like what we see, the picture we see here, the first thing you look out for in any data modeling, I think last week we mentioned it, is the entity. Is the entity. And entity is what? Entity is represent a person, a place, a thing, an event, or concept about which the organization collects data. Please understand this part. Know this part. It is important. In any data modeling concept or approach or language, you are looking forward to the first thing you are thinking of is the entity, or what we call in other realm as objects. So these entities are nothing, but they are things of like such as person, things such as places, things such as things about things, such as events, like classes is an event, admission is an event, and so on, or concepts about which the organization collects data. So the concept of the business. So if you are doing any business, like you are in a hospital management system, there are concepts such as what? Admissions. And when in that kind of concept pertains to hospital setup, admission, or consultation, what happens? It is an activity that you can collect data from. Okay, so then anything that can give you data is what you are centering on as what? Entity. So in a business field like this, in a typical business environment, customer represent one of the company's customers. So we have customer as an entity. And even in customer, we can differentiate between corporate customers and individual customers. And we can separate them because so far as the data they provide for the entity customer has different categories of customers, and each category provides different aspect of data, then it's a different subject. So the far as it becomes a different subject, it represents itself as an entity, or it stands as an entity. So we have individual customer represent a customer who is an individual, and a customer contact represent a person employed by the customer who serves as what? As the contact person for a certain company. So something like this, we can say that we have corporate customer, we have individual customer, out of customer. So these are some of the things, basic things we'll be looking at. So if you rent a car while traveling, you are an individual customer of the rental car company. However, if a movie production company rents vehicles for use by cast and crew while on location, the production company is a corporate customer. So even though we can say that one entity of a certain business is the customers, is the users, is the clients, okay, there are different categories. If we can differentiate them, we should do that. You likely notice that the corporate customer and individual customer rectangles appear within the customer rectangle. So for instance, they are all customers. So there's technologies and processes, procedures. So even though they are all customers, so far as we can differentiate 2 or 3 different customers, we will have to process them differently. That is what it means. Okay, so major elements. So we are looking at elements of information modeling. One major element we are establishing now is entity. An entity is about a person, a place, a thing, an event, or concept. So any of these things that you come across in any business concept or domain, any domain you are operating or trying to model information from, and you are looking for the entities in that domain, you look for the persons, the personal systems or personal structures, things that are of personality, okay, things that are places, things that are about things, important things that are kind of events, and things that are a certain concept within that domain. These are things that you can classify as entities. So these are things you need to identify and look out for. So customer represent, and like I said, example here is customer. Example here is customer. And even that, after you have identified the entity, know that there can be some sub part of the entity or subtypes of the entity. So look for that as well. So when you get the entity, it's not the end. So we find an entity, a typical example of entity as what? Customer. And then we realize that a customer can be corporate customer as well as individual customers. So these are the distinctions you need to assemble, okay, before you proceed. So one major element of information modeling is what? Entity. And that is what example is what I have found. What are the other examples? In a typical school system or university or a database about a certain school, what are some of the entities you can find there? Based on looking at the personalities aspect, the places aspect, the thing aspect, the event aspect, and the concepts. So in a typical school system or a typical school environment, if you are to model the information of the school, you have to look for the entities in that school. And the entities can be what? The student itself is one entity which comes under personality side. Students, it describes the student. The way you describe the student is there's a personality side. Faculty or staff is also under personality side. These are all aspects, the types of entities. Then about places, what can you think about that? Location or department? Department location. Department is a place that the people belong or the people sit. Or residences. Residence is also another place. We can talk about it as a place. When we come to events, one event, common events, classes. Classes is an event. It's something, activity that takes place in the school. Classes, as we are doing a class now, a class for this has data. Some of the data is the class name. The data is the class period. The period of the class is the data. So we need to know the class first before we know when it happens. Okay, it's an event. One thing that we can say is a thing is what? Courses. Courses. The courses, the programs, they are also under 10. Okay, and one concept that we can use, admission. In school environment, we admit, we do examination, transcript processing. These are all concepts in the school, not in hospital. So you see the difference. The concept belongs to that environment and differ from the others. Unlike we can say that in a lot of places, like employees are all over in most organizations. So concept is also another thing you can gather data from. So in anywhere you are modeling, any domain, look for these things: the personalities, the places, the things, the concept that are associated with that domain. So these are the entities I'm talking about. So with that, you get the entities. When you come to hospital, a typical example quality. Okay, the facilities there can be a 10 or 10. Admission can be events that happen in the hospital. The concept of drug administration, the concept of laboratory setup, they are all there. So these are areas you need to focus on. So the first thing your mind shifts to is entity. And by entity, what else? We are looking for the important things like person, place, thing, events, and concepts. Event or concept. Some places it can be an event, like movie events, movie. Some places can be a concept. And when you get that, you go ahead to also look at the subtypes of that individual entities you have identified. So we see from this example we are doing that customer can be corporate customer and individual customer, and they are all entities. They are all entities. So you can see the subtypes of the entity. So basically, this is one element. Entities. Then the next element, you see that from the customer, or whether you are a corporate customer or you are individual customer, we get you another thing, customer contacts, the contact details of the customer. And so we see that there is a link moving from one entity to the other. And that link is nothing but what we call relationship. Relationship is another element that we need to find. If you are going to do relational data modeling or model in relational databases, then you need to be able, the elements concerned are the entity as well as the links. The links, we call it what? Relationship. So we also have conceptual data model. It's high level model. Okay, that's where we are. So we have passed here. Okay, so for now, we can see that there are symbols we see. The relationship is a link that denotes how the degree of the relationship. So the line between the customer and customer contact entities. So we have the customer contact as an entity, the corporate customer as an entity, or the individual customer. So whether you are a corporate or individual, you are a customer, but you link to what we call one important entity called customer contacts. Okay, and entity is so the link between them is what we call relationship. And under this relationship, we will learn other things. We will learn like it's a line with symbols on it. Right now, the symbols on this line, when we see, it depends on the notation we are using to draw the model. How you want to draw the model, though, you make use of what we call notation. Notation is drawing a star of, you can draw a certain model or represent a certain idea. Notation. And these ideas, this notation differ. There are different kinds and types. They differ one from the other just by the way it looks like, but not the meaning. Sometimes you see the meaning of the data you have gathered is the same. If you represent it in what we call Shen notation, it will be different from when you represent it in Crowfoot notation. or it will be different from when you do it in Ellis Baker notation or in information engineering notation. There are different kinds of notation, all from researchers. Researchers have done much work and represent their ideas in different ways. But then the meaning of these ideas or this representation are the same. So it cuts across everywhere that from this point, we have a customer related to customer contact. No change. The way the relationship will be done or the way the representation will be done is what will differ. But as to the meaning of it is the same. If we gather our entities and we try to relate them, it is the same across all notations. It is the same across all notation. So the notations are many. Whichever one you try to use, okay, should give you the same meaning as the other. So that is what we should know. So, but the major things we consider in every relationship is the degree of the relationship, as well as the cardinality and optionality of the relationship. So 3 things we must know from each relationship: the degree of that relationship, the cardinality and the optionality of that relationship. And so here we see here that the link between customer and customer contact is one customer has 0 or many contacts. So one customer here, each customer must have 0 or many contacts. So 0 to many. So you see the sign at the last end of the relationship is in a certain format like crow foot. It is represent what we call many. And then from the beginning of the link, from the customer side, when we see double line here in this representation, it is using what we call crowfoot notation. And crowfoot represent one to many in this way. But the round thing we see before the many comes is the optionality and the cardinality. And this here can be what? It says optionality is 0. Optionality is 0. So here we can have 0 or more. This simply means 0 or more. 0 in the sense that we can have a customer who don't have a contact. Yes, if the customer is individual, does he have a contact? No, he himself has a contact. He himself will give he would represent himself. So that is why immediately you see that the cardinality will be 0 or more. Even though it's 0, some customer, like corporate customer, can give more than 1 contact. They can say that if you don't find us in this finance year, maybe 3 to 4 contact numbers. Okay, so this is how you first of all look out for. You look for the entity and how to relate the entities. You look for the entity and how to relate the entities. And based on the notation you use to draw, the representation or the visual representation will be different, one to the other. Will be different one to the other. So importance of data model. Why is it important? Based on increasing pressure to deliver information system more quickly. Sometimes the companies are, the clients or the requesters of the information system, they are in a hurry. They are behind schedules. So they need something quickly to do their work. So why should we spend time and resources on data modeling? The simple answer is that experience has shown that the more time within reason that we spend in the area requirement gathering and design stages of a project, the more smoothly the construction and implementation phases go. You don't want to spend money to start thinking of creating an information system that you have not modeled it, that you have not given it a special thought, that you have not tried to understand it well, that you have not begun the work of analyzing and eliciting your requirements. Without that, at the end of the day, you may waste your resources. You can get to the middle and get stuck. A lot of development projects get stuck because they didn't start on a good note. They didn't start well. They didn't model it first. They didn't utilize the opportunity to understand it, to try to brainstorm and get architecture. So when you are going to build a house, so model is like building a house, which what we call a building plan. If you don't give it to an architect to be able to think through what you want to achieve and get you a plan, which is pictorial representation of what you need for you to understand and accept, and you go ahead, oh, put one bedroom here, put another bedroom here, put this structure in, the toilet and bath should be here. At the end of the day, you get a mess. It's unplanned. For anything you don't plan for, you don't succeed. You don't get the good outcome. So that is why So you need information modeling. You need information modeling. And to do that, you look out for what another element. We have seen two elements already. We have seen, even though we'll come back to it, we have seen entities, we have seen relationship. The next thing is business rules. And business rules are in two forms. They are constraints and assertions that define the way a business is run. That define the way the business is run. So the domain you are going to work with, it falls under a certain business market. When even if it's a model so and so hospital, it belongs to the market of medical health centers. Okay, so everything you do must conform to the standard in that market. And also the way you want to achieve your aim and objective of any business aim and objective is what? Making profits and also producing the best or the quality stuff. And you do that with strategies. You do that thing, you achieve that objectives and aims of your organization or what your mission statement is and your vision and your steps or operational procedures should conform to the best ability to gain the market's trust. The market is the operational, the domain you are operating. If you are in health, there is a lot of people into health. If you are in marketing or shopping, there's a lot of businesses under shopping. In terms of shopping, we have ShopRite, we have Mercom, we have Palace, we have all the departmental store, China Mall. These are all competing together, one after the other, competing among themselves. They belong to one market. The market is the domain of sales. Okay? And so how you will behave in this market to be able to succeed is the business rule. The business has standards they operate. Like you buy we assess your things, we give you invoice, or you pay for it, we give you receipt. These are standards. How to buy and how to sell, so that you alone, people will come to you and buy things. It is what? It is the business rule. Let's say everyone who buys a certain rate or a certain amount, we give the person 20% for next shopping. It is a business rule. It's not a business standard for everyone to follow. It is only your organization or your sales business that is doing that. That becomes your sales business rule, and not applicable to everyone in the market. So that is business rule. It's one of the elements of information modeling. You need to know how realistic and competitive strategies to beat the market, to be number one in the field the domain you are operating. And so good computer systems follow and enforce the business rules. Some of these rules are well suited for enforcement by the database, while others are better suited for enforcement within the application system and logic. So there are things that the database can consider to actually take care of. And there are also things that you apply them, or you put them in the application system. And sometimes both. So business rules are the ideas, the strategies, the way of life that you apply to your business to make your business succeed and compete well and gain the major part of the market the business belongs. It is what we call the business rule. The business rule. So in conceptual modeling, for instance, assuming this is a typical example of a certain model, this is a company, okay, that does work in the, so this figure shows part of a conceptual data model for online movie rentals business, or an imaginary video rental service. What are some of the things you think about first? Entities. So what are some of the entities? You are doing movie rental or video rental service, and you are in a big market. Everywhere you go, people are renting movies and videos. So it's a market, and your main focus and aim is to lead that market, to be the leader of that market. Should be the leader, the organization that when everybody wants to rent movie, they will think of you first. They won't go to the next person until you do not have, or until you run out. And if you do that, you are breaking your front. So you should also make sure you never run out. That whatever kind of movie anybody wants, the person can get it at your end. And when you do that, you need to apply a lot of rules and principles. And these rules and principles are what we call business rules. So the business rule will enable people always look at you, because there are standard operational things for all the people. Everybody knows if you want to rent a movie, you go online, you search for the movie name or the date and the time, and you rent. That's standard. But what about reducing your price and cost? Said that at any time you are the lowest in the price, people will always come to you. People will always come to you. What about being customer-oriented focus? So that you think it's a business you do with people. What about strategizing such that everyone you come across your website, you actually embrace the person, you treat the person well, you answer the person's questions well, you do follow up with the person for the person to feel comfortable and at home doing business with you. And that is customer focus oriented. And if that is the case, then you don't have a problem because every now and then everyone will look up to you. So conceptual modeling figure, this figure shows part of a conceptual data model, part of it. And at least we can see that if you want to rent movie, one major entity will be customers. Who are the people coming to get the movie? Customers. And there should be some employees who will be taking care of what? These customers. There's also customer payments or accounts, customer accounts with you that makes you be able to take the movie away. Okay, so there should be customer accounts created. So you realize that whatever domain you are operating, there is a way things are done already. That standard operational rules or way of doing things, it is applicable to everybody in the business, and that is what you first have to consider. And some of these things that a customer is the one who go and rent a movie. And during the rental, there's what we call activity happening, the rental activity. The rental activity happening is more like transaction. It's an event. It's an event. What happens? What happens? You give each person that have to rent is one transaction. So you have to identify the transaction ID. Okay. And every renter involves a customer and an employee. There should be one employee helping you to or assisting you to rent, to know that you have done the right thing. You need this thing. So the employee will pick it and parcel it and forward it to you in whatever means of transportation it will use, or whatever means you will get it. That is the employee's duty. So these are some of the basic entities you will find. The customer, what do you need from that customer? We call it attributes. Attributes. You need the customer details. The characteristics of the entity is what we call attributes. Characteristics of the entity. So if the entity is a human being, you are thinking of the name, address, city, state, province, every detail about the customer, and the country, as well as the business phone. Some of these things are important. And then also you look for trying to identify each customer uniquely, because you can't say customer one with him, and when another customer comes to you, call the person customer one. You need to identify each customer on your system. You don't use a thing. So you have to find a better characteristics customer, and that's nothing but customer ID. Then the company, it can be a company renter. So like I said, it can be a customer or a company. So the company, if it's a company address, okay, company city, company state, company country, company business phone. If it's individual to address. So one important things you need from the person are these things. And then the account number, the customer account. Because you need to have an account that I will bill you in. Even if it's credit, I will have to bill you. So one day you come and pay me, or I will find a way to get my money. Okay, so definitely you are renting, and it can be, you can rent it 3 days and you will not return it. And so I will need to put some commission or something, charges against that. So all these things are important. And of course, your credit score, if it is a normal business process that we think that we are serious, there should be a way to know your stand, your status, or your credit status, or your credit score. So your account number is one, the credit score, the balance due, the last bill date, the overdue amount when necessary, and the customer ID, because each person should have an ID. Each person should have an ID. The customer have an ID, and the account number should be associated with the customer. So the ID must be reflected in the account number, which becomes a foreign key, which become last semester we did primary key, foreign key, composite key, candidate key, super key. We did all that. Okay, so the customer here in this case, so far as it is a primary key in the customer entity, when we come to the customer account entity, it will be a foreign key, and the account number will be the primary key. Then we come to what we call transaction. When the exchange is taking place, when we agree and endorse your renting, and we say we'll give it to you, it is one transaction. Another person too will come. Another person too will go. So in this transaction, we'll look at what? First of all, it should be involve a customer. The transaction that is happening has a customer ID and an employee ID. And these two will be the primary key. So in this way, we'll have a composite key for transaction table. Either we do that or we use transaction ID. Sometimes you just don't want to, you want to avoid composite keys. So then you can give a unique identification with the number. So each transaction is tracked and recorded, being given a number. So we can have transaction ID as the transaction key. And it involves customer ID and employee ID. And so since employee table has employee ID as its primary key, or employee entity, at this point, let me get used to the entity. So we have a customer account, we have customer, then we have transaction. And we see that a customer ID is the primary key for customer. And the account number is the key for the customer account. And since where we have the customer account, it will definitely involve the customer itself. So the customer ID becomes the foreign key there. So as we have, then we have movies. We have one entity called movies. That's what we are going to do actually. So movie is the movies. And the movies are running through the transaction. And here we see that the relationship between, okay, so we have to also, so this notational representation of this information is in Crowfoot notation. When we represent this in Shen, the idea, the concept, and the accuracy will be the same, except that the pictorial representation will differ. Instead of what we see, we'll see something else. We'll see something else. The structures and the relationship links will differ a bit. Depending on what we use. So the label items, entity, attribute, relationship, business rule, and intersection data illustrate key concepts. Yes. So the elements we are looking for are the entity attribute. Attributes are nothing but when we see transaction and we come here down, we will see all the other elements that will help us link together as a family. Okay, so we have the entity, the attribute, the relationship, business rule, and intersection data as well. So movies. Okay. Model we see here is a typical example of trying to create a typical model in so when you see we have how many entities now? 6 entities. Okay, later we'll see how they relate to one another. We'll do that and so on. So what we are looking at are the various elements. We say this is an entity, the customer, the headings, customer account, transaction, employee, movie copy, and movie. They are all entities we have identified. And how you identify them, like I said, you look out for the name, the phrase, the person, the name of the person, the place, the thing, the event, the concept. So when we look at movie production or movie, we see that movie renter, customers will be one customer. And the customer accounts have to come. And the employee, they are the personality, the persons, customer, employee. The activity, okay, the place. In this case, we can't pinpoint any place, but we can pinpoint event in the movie rental, which involves the movie itself and the movie copy. And the transaction will be the event where the movie rental takes place. And always the event takes place daily. In a typical database or in any database, we have what we call transaction tables or entities, and we have master entities. In this case, movie is a master entity. It will describe the movies forever. Customer is a master entity. It will describe the customers. Okay, employee is the master entity. It will describe all employees. Then transaction is the day-to-day activity that happens where people take the movie away. So it involves the customers, the employee, then the rental date, the date you are renting, the due date, the total rental fee. After you give me the due date, I'm able to calculate your total rental fee and also give you late fee. In case this fee does not come, your late fee is this. Your late fee is that, and so on. And then there's what we call movie copy, which actually is coming through a situation we find between movies and transaction. Between movie and transaction, it is more like a many to many related to intersect data, intersection. Most of the time, you see those entities, the name is similar to existing ones. So here we see the name as movie copy, which shows the movie ID, okay, from the movies, the copy number, okay. Then we have acquisition date, the loss or sold date, the media format code, and so on. So these are the entities. The link between one entity and the other. We know that a customer will be related. Anytime we have a foreign key and a foreign key, it relates to where the primary key is. So we see that here in the customer, it is customer ID as a primary key. But when we come to transaction, we are dealing with customer ID and employee ID, who are all foreign keys, which are all foreign keys because customer ID is already a primary key here. So if it's reflected in the transaction activity, then it means that it's a foreign key, same as the employee ID. And so definitely, so far as we have foreign key, customer ID, and employee, in the transaction table or entity, transaction would relate to the two of them. And that's why we see transaction relating to customer table and also relating to employee table. That is simple. One way to relate tables or entities. And then we have a transaction relating to, because what actually are we transacting in? We are transacting in a certain what? Movie. Okay, you are picking movies. And so I give you rental date and due date and total rental fee and the total late fee based on the movie you are taking. And that's why transaction relate to what? A movie. And the movie, because the transaction will relate, many transactions relate to many movies. Transaction 1 will contain the same movies that on it as transaction 2, and so on. So that's why movie copy comes. So you relate, you intersect another table for the relationship to be acceptable or completed. And so that's why you have intersection entity as what? Movie renter coming in. Movie renter. So we have here these two. Before these two, every movie has a certain copy which has a name, movies. So movie title, the general code, the MPAA rating code, the list rental price, the list sale price, the production year. And then that is one movie which relate to what? Many copies. Many copies. So because the same movie, 20 people can come for it today, the same movie. So you need to have more copies of the movie. We have movie and we have copies. So when we look at the movie copy, that is relating to the transaction. So because the movie is a movie, but we are dealing with different kinds of the same movie. When you have one movie, it has many copies. So which one are we talking about? So that one is a copy of that movie copy. And so to be able to relate, this transaction can be many transactions will be dealing with the same many movie copies. Okay, if that is the case, then there should be a way to relate it better. And so even though we have transaction ID, we are also going to have a movie renter, which will be relating to the copy, the movie copy okay, as well as the transaction ID and the movie rental ID. So the movie ID and the movie, so this movie rental is coming to help us get a flow, and we will deal with those many-to-many relationship later. But for now, because of many-to-many relationship, we have intersected an entity here called movie renter. Transactional activities about renter. We could have called it movie renter transactions, okay? But movie renter here and copy here. So basically, in the end, after everything, we'll get seven entities, and which are related well. So we see that because there are 3 foreign keys here, this movie renter will relate to what? Transaction, as well as movie copy, and also will relate to the movie itself through movie copy. So we'll have this relationship done, and so on. So that's entities. So an entity or entity class, is a person, a place, a thing, an event, or concept about which data is collected. Take note. Entities are the real world things. So when we look at the movie concept, the entities are customer. It's a real world activity. We know it. Based on the issue of movie renter, the moment you hear movie renter, what comes to your mind? Customer will go and rent movie. So movie is in it. Customer is in it. Customer account will come in. Employees will be supported. And the movie rental activity or event will take place. Then transactions will take place. So we go here, we see that entities are the real world things. So entities that we are talking about, they are not from anywhere. They are real world things in which we have sufficient interest to capture and store data about them in a database. So when you are doing a database, how do you get the data items such as name, student name, student date of birth, student gender, student department? This comes from the entity students. And the description of the entity is the characteristics that gives us the data. So take note, the description or characteristics of every entity is the one that provides us with the data we need to store in the database.